Let's start off by a scenario. It's 2:37 a.m. You get waken up by your phone, and you hear your CEO's voice in a panic, and it tells you basically that the company's application has been down for about 3 hours now, costing you guys millions in revenue. And as you frantically try to restore these services, something is like in the back of your mind, right? Could this scenario been prevented? Could you use AI to identify and test these failure points before they even began? Before this 3 a.m. crisis. I'm Narita Wu, and this is Hans Nisbet. And today, in the next 60 minutes, we are going to show you how combining generative AI and AWS Fault Injection Service will save you times and effort into testing in today's, thank you, not just by helping you discover unknown risks, but also turning past incidents into automated tests to prevent history from repeating itself. In the past year, 50% of companies suffered through more than 10% or 10 hours of downtime in the cloud. While systems fail, something far more valuable begins to crumble, right? Customers don't just get frustrated, they left. Leadership didn't get concerned, they lost confidence. Investors didn't just ask questions, they lost trust. Revenue didn't just dip, it disappeared. Here's the reality. Everyone talks about resiliency until it's that 2 a.m. call while everything breaks. The question isn't whether you can afford to implement or invest in resiliency. It's whether your business can survive from it. Everything fails all the time. We need to build systems that embrace failure as a natural occurrence. When Dr. Werner Vogel, VP and CTO of Amazon.com, said those words, he was defining a fundamental truth of modern day cloud, right? We've heard of this saying all the time. But this wisdom drives our shared responsibility model. AWS ensures the reliability of the cloud while you architect the reliability in the cloud. It's a partnership built on reality, not wishful thinking. The most resilient organizations and customers aren't the ones who believe that they can prevent every failure. They are the ones who embrace this quote by Werner Vogel, and weaving resiliency into every layer of their architecture, transforming this shared responsibility into their competitive advantage. So let's talk about how our journey is going to unfold today. First, we're going to talk about how generative AI can be used to be your early on detection, discovering failure scenarios that you haven't even imagined yet. And think of this as architecting who's constantly asking, what if, right? That little mind in the back of your head saying, well, what if? Could you do this? Could you do that? Next, we'll go back behind the curtain and see exactly how this works. No magic, no buzzwords, no, oh, let's see this. Just practical implementing technology that transforms how we're approaching resiliency testing. Then we're going to tackle how equally crucial, challenging, or critical challenge within it, and using AI to validate these failures that are already known. Because let's be honest, how many times do we think about when we test or when something happens, could this been prevented? And then finally, this is where it gets a little bit more exciting, and the actual thing that we're waiting for is we'll show you how to put this into action. Not next quarter, not next year, but by tomorrow or bringing it back to your teams, you'll be able to implement this all together. These are going to be through real-world scenarios, practical coding that will be provided, and then also give you everything you need to get started. And then by the time you're done with this, you'll have a new approach to resiliency, and it'll get testing and get the power AI into your resiliency testing altogether, turning months of work into weeks. And then we're going to show you how this all works. So Hans.
Thank you. All right, here is the Resilience Lifecycle Framework. Has anyone seen this before? It was released in October of 2023, so it's been around for a reinvent or two, and there's a QR code at the bottom if you want to check it out as well. But this is our North Star when we think about building resilient applications. And today we're going to spend some time talking about where does Gen AI or agentic capabilities come into play in this life cycle. So you may see it's not pointed at the top where set objectives. Set objectives typically is, when we talk about recovery time objective, recovery point objective, RPO, RTO, and our SLAs. These are typically business decisions that are made, and then those requirements are then given to teams to execute on, right? So those are business decisions for set objectives. However, then we move to design and implement, where we take the RPO, RTO, or SLAs that we must provide to our end users. And this is probably the most common place where I've seen agentic capabilities so far. We saw announcements this morning, or more talk of Kiro and Kiro CLI. How can we use these agentic capabilities to, one, create our infrastructure as code, right? Make sure it's across your availability zones, make sure your database is configured in a highly available fashion. But also when it comes to building our applications, right? When our application code, we're writing that, can we make sure that we're adding backoffs, retries, baby jitter, and having proper instrumentation for observability? We want to be able to answer the question, where's the challenge? What instance is it coming from? What service is it supporting? What availability zone is it living in, right? Where is the pain? Let me find out very quickly. But once we've designed our system and implemented it, we can then begin to evaluate and test it. And here's where we'll be spending a good amount of our time today. Once I have that infrastructure, how can I use agentic capabilities to help me discover what fault modes it may have? And how can I build tests to help me validate my application is resilient to certain scenarios? From there, we operate our application. We saw if you guys watched Matt's keynote this morning, we saw the announcement of the DevOps agent as well, right? I think of the DevOps agent when I think of operate, or there's CloudWatch Investigator as well to help us determine what's going on in the environment and shorten our mean time to recovery to bring an application back into service. And as Nareda was talking, like 50% of organizations had incidents, and commonly after incidents, we produce root cause analysis, right? Your teams probably do something similar. What was the challenge encountered? What was the timeline associated with that? What events came together to make this impairment happen? And then how can we use that data to recreate a scenario to validate all the checks and balances that we put into place after an impairment did what we want them to do, right? We don't want to just add retries if that was what caused the error. We want to validate that made the impairment not happen again, right? We are resilient to that impairment in the future. Okay, before we jump into our demo, let's talk about what application we'll be reviewing. Here we have has everyone dealt with a 3-tier application before in some form or fashion? Whether they were on-prem and you migrated to the cloud, or just have built a monolith, but we have an application load balancer. In our case, we have a Windows EC2 instance, or a set of EC2 instances, backed by a relational database, and this one a MySQL database. And so when we start to do our discovery, we have 2 agents that are built and backed by Bedrock in this case. So we have our inventory analysis agent. Our inventory analysis agent will go help us discover what is on the box and help us determine what failure modes or scenarios are associated with that failure. And from there, we have our document generator. Document generator, there is a integration between Fault Injection Service and Systems Manager documents or automation that for the actions that are not native to Fault Injection Service, we can write automation documents to facilitate these, right? For example, impairing IIS is not a default action. However, we can write a document to go do that for us, right? And so this document will help us create those impairments. And one thing I'll also call out here, you may be thinking, Hans, isn't there a service called Resilience Hub? And what is the difference between what you're saying right now and what Resilience Hub provides? Resilience Hub is focused on your infrastructure, and so it can determine, you have auto-scaling groups associated with your instance, you have multi-AZs and all that stuff from an infrastructure perspective, but it doesn't have insight into what's running on your EC2 instance. And so pairing this capability with Resilience Hub gives us that powerful, how can we take this to the next step? Okay, in our demo today, we're going to show a the agent's running, it's going to review what's installed on an EC2 instance. It's going to help create a hypothesis of what impairments we could facilitate on that instance based on what it finds. And then we're going to see a document created based on one of those impairments. Okay, here we have our agent. So going to start running the agent now. It's going to start identifying what's installed in the environment. It's using the use AWS tooling to configure what is the network settings. We start to see there's one instance now that it's online. It's associating with what's running on the server. We see that it's installed with a IIS application. It's understanding what the database connectivity looks like based on what it's finding. And we review the prompts for these in a little bit for how we steered them, but then it's able to start creating chaos engineering and hypothesis based on what it found. And you see at the bottom, we're excluding some things as well. We don't want to test Microsoft Edge. That's not part of our application, right? We want to make sure we're focused on application-specific things. Now you'll see the data that was discovered is being passed into our document writer agent, and it's going to start creating a document to facilitate an impairment of IIS on that box. So the systems manager document will run on that EC2 instance. There is an agent that is on the EC2 instance that facilitates communication between the EC2 instance and systems manager, and that's how we will invoke this document on that box. And so here we can expand the capabilities of what's native to Fault Injection Service by utilizing that combination to be very application specific when we're testing things in our environment and not just utilizing the built-in FIS actions, which are very advantageous as well. Okay, so I know that was a little bit of scrolling. So let's go back to our presentation and take a look at that and what the output was and talk about some of what it found and how it deduced these things. But you may have also asked yourself, how did you do all that? What lines of code? That must have been terribly many lines of code that you wrote to go run those agents. So here you can see the couple lines of code. Here we're using the AWS Strands framework to facilitate the building and running of the agent. The AWS Strands is a simple yet powerful SDK that takes a model-driven approach when building and running agents. So you can see we specify a couple things here, the model, which model we want to use, the tools associated that we want to give it, right, to arm it with the actions to go discover things in the environment. We have it a prompt and a callback handler so we can view what's going on from a logging perspective. One thing I'd like to call out here is the Use AWS tool. This tool was built by AWS, but it allows you to then discover and allows your agent to have context of the AWS APIs and services. So when you're asking it, go to Systems Manager Inventory and discover these things, it understands what you're telling it. And then we have another tool here that allows it to understand tags across an environment, right? Two powerful things to go give me context in there and then understand the ecosystem as well. So not very many lines of codes to build and create that agent. Okay, now let's take a step back and look at the scrolling text from the agent, but maybe a little bit slower. So here we see that it's found a web application server running with a couple services. So I like to think of this agent as the infrastructure detective. It's able to go run on the box, discover what's running, and start building context of, based on what's running, what failures can happen, right? Again, when we're thinking of large language models and agentic capabilities, we want to think about how can we arm it with the context it needs to be successful, right? So another helpful thing to add at this stage is not just allowing it to inventory what's on the agent, on the EC2 instance, but also maybe providing the application code as well. But by providing the application code, we can understand how does it then retry and back off, and I can have better hypothesis based on what will actually happen when it's impaired. How does it act, right? By pairing those two things, we have much better context on how the application handles scenarios. So discovered IIS that's running. It also begins to discover that there is a ODBC driver for a SQL Server installed, and there is no SQL Server installed locally. So we can then begin to deduce, okay, this has external dependencies on a database, And if we use that tooling, that tag tool as well, we can then begin to learn, okay, what, if we're tagging our applications or if we have them added to a resiliency hub, what actual database is associated with that application. Because ideally, I want to probably go do some impairments and play with that connectivity. When we start thinking, throughout the scrolling there, some of the interesting things, it started suggesting also that our native actions to Fault Injection Service are like the AZ latency, which was a announcement a couple weeks ago that we released rather. So it begins to discover all these things and put them together with context. And so with understanding how the application functions, how the application code functions, and then knowing about the environment. Is it part of an auto-scaling group? How are the health checks configured? We can begin to put that picture together and understand that this instance is actively serving traffic, and if these services are disrupted, the web server would stop serving this purpose. However, with the way auto-scaling is configured, once it begins to stop serving the traffic, the instance will be replaced. So we will have a healthy instance take over this instance and begin to serve traffic again. And I know when we're thinking about having been on infrastructure teams in previous lives that weren't the infrastructure teams that were supporting an application, sometimes you're in scenarios where the people supporting the application may not have full context of what the application code does, right? Or SREs that support applications, but they may not be the ones that build it as well. And so having capabilities like this to build hypotheses based on what that service actually will do and how it runs is very advantageous, right? Especially if we don't have all the context or familiar with it for a long time. It helps speed up the failure modes that I'm aware of and help me execute tests on those. Okay, let's talk about some of the documents that it would then write based on what it found. And these are the non-native actions that we're talking about here. There were other native actions like AZ latency or AZ impairment, the power interruption that it would suggest as well. But let's talk a bit again about the non-native actions that it would then suggest. So here we have a database SQL port blocking. So it would go and manipulate the security group on these database servers to possibly block all the security groups from the web application servers, saying I'm not going to let any servers communicate between these two layers. How does my application handle? Or we can also have the scenario where maybe we're going to block a specific instance's IP and then determine that our observability platform allows us to observe what instance is having the blockage, right? We should be able to determine it's one instance within this AZ serving this service, and now I can go take action and bring this back into service faster. So some good hypotheses we could observe and learn about our application and how it handles based on this scenario. And then again, what happens if we impair the IIS service or the application pool that's serving traffic? Will it continue to try to serve traffic? Will clients retry? How will this happen? What will I observe in my platform? And based on what the agent hypothesized and discovered, the healthy web servers will be replaced and this service would resume normal operations. And again, having it have context of the auto-scaling group and health checks, we could then also infer how long that would take. Would it take 5 minutes based on how everything is set up? And so this helps you build those hypotheses much faster without having to do a full discovery of what all the failure modes are for your application and making sure all the stakeholders who have the knowledge of that application are there as well, so you can have a meaningful conversation on how does the service function, how does it retry, how do we believe it will act in these scenarios. All right, and back to Narita.
So let's talk about some of the prompt engineering and what helps us kind of guide our agent into understanding what we want to do. Now, think of these prompts as a detailed job description for what the agents are going to do. So within that scenario that Hans showed us, this is where we're guiding that agent to do that. Now, for our inventory agent, we are being very clear on what we want it to focus on. And that is really thinking about the applications and your servers on what to avoid what is patches and updates and mostly focus on business applications altogether. Now, why do we say ignore patches and updates? It's not really relevant to what we're going to test, right? That is maintenance, that is routine. That's not going to show us what is focusing on resiliency altogether. With our automation agent that we had showed earlier, that's the same mindset that we're going with. The same focus, being very specific, never touch protected services. We want to test resiliency. We don't want to break it. We want to be able to recover from it. And so in each prompt that we have guided our agent, which we'll show you, it's kind of defining, one, what do we want to do? What can you do? What is their role? And then secondly, we're focusing on more of what can it not do. So we have to focus more on what it can and cannot do so you can guide that agent. And then formatting, what is that response that we want it to look like? And so there's a balance between our agent being intelligent enough or effective enough to be able to give us what we want within the scenarios, but also constrain it so that it doesn't do everything that it wants by itself. So we're putting in those different guardrails for the different agents. But before we even get started into understanding what our agent is going to do, we got to understand what is on our actual nodes or instances, if you would call them. And so we're working with an idea of, if you're an architect and you're looking at building blueprints, you got to understand all the different components, right? The systems, the connections, everything that it has encompassing, so that you can understand what the integrity of that building is, right? Same concept here. So we're using AWS Systems Manager Inventory. That's going to be our blueprint reader. It's going to tell us what is on the node, what is installed, what it needs to be updated in the sense of what is already on there. And so our first step is understanding what's it being on the node. Really understanding what is installed from the software, network configurations, what database connections that node has, that traffic that it's pulling, all the critical components of the application that it makes up. And this is where it gets really interesting by combining Systems Manager Inventory with Fault Injection Service, FIS. We're really bridging a solution together to kind of experiment with expertise, or understand that instead of throwing chaos, we're experimenting with precise, controlled environments to understand the resiliency. And the difference really is thinking about when you're testing, you want to understand what you're testing for. So being controlled and concise is what our end goal is. And by combining these two, we're creating that solution and making things that are actionable afterwards. Oop. Wrong clicker. So let's talk about our first agent, the inventory agent. Now, our primary directive to this agent is looking at, if you look at it, it's saying running an online EC2 managed instances. This isn't by accident. We're being very precise on what we want because, one, we want reliable and actionable data that we can make information based on this. We don't want to do anything with offline instances. And the two main key phrases that you can see is running online and managed instances only. Online EC2 instances, we only care if they're online, like I mentioned, and actively reporting to Systems Manager will allow us to get that reliable, up-to-date data from our nodes. Now, think of this as setting up the guardrails for our agent altogether. We're not telling it, we're not just telling it what to do. We are focusing more on where to look, what to see, and what to look at. And so by using our prompt engineering, we're basically saying that this enables us to be more consistent with what we're targeting so that we're removing that noise and only focusing on what is our end goal. Now, here's where we're telling our agent what not to do, right? We said that you have to focus on what it can or cannot do. This is saying what we don't want it to focus on. So we're very adamant about not looking at patches and updates. Why? It's very simple, right? Like I was mentioning earlier, you're not going to really want to focus on what KB entries you updated and installed last week. It's irrelevant to your resiliency testing. You want to remove all that additional noise to get more precise and control experiments. And so what we really care about, and from a business critical standpoint, is what web servers are serving traffic. What application is processing all those different transactions? What databases are the different connections handling that in the customer data altogether? By really telling our agent to ignore the rest of that information and being very clear and precise, we're turning that into actionable insights, and we're not just being wishful thinking that it's going to understand what we're doing. And so focusing on this approach, we're really letting our agent analyze the different systems and look at all the components that matter that are going to impact your business and not getting distracted by everything else that might be installed in the node. Now, let's kind of look into the constructive side of things. What our agent actually does on the node that you're telling it to do. Think of this more as a 5-step discovery process, looking at everything that it's building, giving you the full picture of what is on your system. We first catalog, what is the software installed on those different nodes, the application. This is that foundation where we want to get that information from. Secondly, we're examining the different configurations and the different packages installed. Now, this is very much where we want to focus to, because it's kind of setting up everything that it's working with, giving those different components. And then third is the more crucial component that we also want to focus on, is really documenting everything that the service and the actual component of the application and their versions. So we're looking at the services and their versions. Why? Because sometimes you might think something is installed on your node, and then you realize actually that version is not the right time, or the runtime is different than what is actually installed on the node. So you want to make sure that those two different things are aligned to what you're looking for, because it might create a disruption, might be subtle, but it could cause a little bit problems down the road when you're testing for resilience. And then now we're also doing, by number 5, is packaging all these different inventory reports for that other agents can be able to look at the inventory report and use it as actionable data. It's always useful to be able to repackage everything, and so if you remember, we're only looking for online EC2 instances and that are reporting. So through all this process, we're only working with online and not offline, because they're not relevant to our testing if they're not in production or within our test, dev, and all in the life cycle. So looking at what inventory does, think of this as a way for you what really matters within your resiliency testing. So starting off with business critical applications, think about your environments and what are you hosting. If it's Java, if it's Python, Node.js, if it is .NET frameworks, you're looking at everything that is within the data layer within it altogether. So when we think about database and the clients and document everything that is on there, that's also a big component into understanding what is happening, right? You want to understand if it's whether Apache, IIS, or if it is Tomcat. They're always the front line of your customers, so paying attention to what is on that layer, you want to make sure that you understand that completely. And now when you think of this, you don't want to forget the business, the customer-facing applications, right? Those are the specific tools that if you either build in-house or if it's a third party, that you actually take the time to look at the custom applications altogether. Now, the key thing here is really focusing on, is it a direct business impact? Yes or no? It's not just creating that one list for you to understand, but it's giving you that map and building out what are the different components that you see within your application that you might have not known that it was tied to your application. Now, one thing you should think about is the thought of 4 questions that build up the backbone of this analysis, right? First is, what is the server's primary role? This isn't just thinking about labeling that server, it's going beyond that. It's thinking about what is the purpose that this server has, if it's beyond those different tags, if it's managing a database, is it running application logic, or is it this is like the fundamental understanding of what the purpose of this database is gonna be, or that server. The second one is what services are actively running and providing business function altogether. Now, this is really that emphasis, and I'll keep saying this throughout the time. Is it actively running? Is it reporting assistance manager? That's where we want to focus our time. Now, this really tells us we should be focusing more on how these failure impacts are going to affect our business, right? When we talked about earlier about how we don't just lose customer trust, we lose different components that we might not see something more valuable in the beginning. And so when we talk about dependencies within the different services, this is where we think about failures. Failures don't happen in isolation. We think about that domino effect. One thing happens and then a bunch of other things happen that we might have not known about. So that is really thinking about what dependencies are within your application while we're testing and what would happen. And now we're moving towards, well, what do these questions help us by providing inventory of our instances altogether? And we're bridging the inventory with resiliency intelligence to give us more of an actionable plan for what we're doing that might fail. This slide represents the guardrails of our agent, what it can do in a sense of protect the different services that you want to be able to either test or not test, right? We're creating an isolation boundary for different resources. Think of this as more of a way to really maintain, control, observe, and if needed, stop as a reaction to not being able to go into a resource. The key message when it comes to protective services is really chaos engineering isn't about random testing. It's not about just going and testing everything within your environment. It's being selective on the different resources that you want to test and make sure the application can withstand it. This is really meant to restrict you or restrict the agent altogether. It's really to empower you as a tester or building that resiliency into your environment so that you do it in a safely manner. Now, this isn't an end-all be-all. It could also be changed. This list can be modified to your use case. And so it continues as we go into what are those key analysis. Now, thinking about what kind of questions you're asking the agent to solve for you, the first one is going to go back to what is the primary role of this. So when we go into what is the primary role of this agent altogether, we're thinking about that core understanding of what is happening within your environment, what it can or cannot do. And really and then once it comes into which services are active and serving business functions, as you could tell, the agent does a lot of similarities between each agent from where we're going from. So when it comes to the protective and versus it coming into reporting, and so thinking about the dependencies is like kind of the same concept as we're thinking, moving into like understanding the application, what is happening with the application. Oh.
Duplicate slides?
I think it does have, sorry, this does a little bit have duplicate slides. That's the part I was looking at. going back to beyond just protected services, think about as a way as remembering. So when we talk about our protective services, that is services that we don't want to affect, but in reality, like using the systems manager, that is a way for us to recover our different nodes if something were to happen. And so that remember statement is more, not just a summary, but more of a design choice that we implemented on there. So it has a purpose. We're reinforcing those mission boundaries of what it can or cannot do, and only focusing on what it should be doing.
Right. Thank you. All right, so Narita spoke on how we can discover things with our agent. Now let's talk about how we can actually take action on those resources. And so we're using Systems Manager documents to facilitate those. So before we jump into those agents specifically, let's talk about what makes a good Systems Manager document. I think one of the most important things that is native to the FIS actions, if you use the EC2 CPU stress action, the EC2 memory stress action that FIS provides, behind the scenes, these are systems manager documents managed by the service team that go into your instance to facilitate those actions. And they are, if you look at those, I think they're prefixed with AWS FIS in the console if you go look at them. They take care of putting the things back in order when they are done. We have to restore the state. If we're stressing the CPU, we have to stop that stress when the experiment is canceled, it fails, or when the duration we specify runs out. And so service state restoration is an important thing that we need to take care of ourselves if we are writing documents that are outside of what FIS actions provide, right? We need to put the resources back into shape that we found, right? And one way to do this is by making our documents very modular. On the right-hand side, you'll see a CloudFront impairment that validates a multi-region CloudFront implementation. And on each portion, on failure or cancel, we're rolling back and reverting our changes to make sure that our service is how we found it, right? We're cleaning up our house. We want to make sure we're idempotent. So for example, the CPU stress action that's native, we don't want multiple actions of those running at the same time. We want one. So how can we do that? Make sure that we do that. And adding preconditions. I think if you saw the text scrolling quickly for the automation document, there were preconditions saying this runs on Windows boxes, we're running PowerShell, right? Making sure we're running the right resources on the right instances. And so this is what our prompt will take into mind when we're building this document. So again, the same concept, we're starting with what is the agent's persona? The agent is a specialized agent focused on writing systems manager documents to facilitate chaos engineering or resilience tests. And it will generate systems manager documents to help create those stress conditions. And again, we're continuing to steer it. We want you to be focused on the business applications you're being passed. You want to be creating very specific things using these documents and automation. And we want to be focused on doing things that are not native to FIS. If the FIS native action is there, I don't want to reinvent the wheel. Use that. It's good. I don't want to handle all those things. Use native actions and only create things for what FIS can't do natively or to go into our box to create impairments. Right, we want to be able to do this on the OS level if needed and implement all those safety mechanisms. And specifically for this one, there was a RAG database behind this prompt that had the blog for how to create what are the best practices for writing documents in the database, as well as all the Fault Injection Service native actions in the database. So we gave it context of what is good, what good looks like, as well as here's what is already invented, don't go do this, we already have it. Okay. And before we run a resilience experiment, we want to make sure there are certain things done. For example, for our IIS instance, we don't want to run an experiment to impair IIS if IIS isn't installed on the box. Is it currently running? Right? We want to make sure, is it online? Is it running? Is my application stable state healthy at this time? Let's validate that. And then after that is if I'm dropping a file locally to make sure I'm being idempotent, is there enough space for me to drop that file without, filling up the drive that I'm dropping that on, and perhaps are the PowerShell modules that I need to facilitate this already installed on the box. So we're making sure, is everything there for me to be successful to create the impairment? So the agent will take this into account based on what was in the database's best practices. But again, reiterating it follow these preconditions. And then once we have the experiment that was successful and gone through, we want to make sure that the house is put back in order. I have a toddler at home, so I'm used to telling him, hey, you're done playing, let's pick up your toys, let's put our toys away before we move on to the next thing. So the same thing is true here. For our IS experiment, is the service going from a stopped to a running state, or started state and then a running state, right? Is everything that we did undone now? Then once all of that is true, remove that local file that you put there for idempotent reasons, right? Let's clean up our house after we're done with an experiment. And the agent will take this into account. And as Narita was saying, that we want to set ourselves up for success with these experiments, guiding it along the way. We don't want it to impair the systems manager agent. I can't restore the state of a system if I can't communicate with it for this one. So leave systems manager agent alone if it's installed in the box. Don't impair that. Don't just do something to critically impair the OS itself, and don't impair the network connectivity between the instance and systems manager, right? We want to make sure that we're able to communicate with it and take action as we see, right? So again, steering it of what to do, but what also to not do along the way. And again, reiterating, you focus on the business application you are passed. You can impair non-critical temporary files or cache directories. You can impair application-specific services, whether these are third-party or custom, and user-level preferences. So we're guiding it along the way of, again, you're past a hypothesis, but remember all these things are true when you're writing your experiment and your documents, to make sure that we're having the best practices implemented along the way and setting ourselves up for success. Okay, back to you.
Now, earlier Hans mentioned how the agent created an automation doc for us, and we're going to take a look on how that actually looks like. So the agent made 3 main critical things where it talks about a validation step. This is where we're running tests and not focusing on already impaired systems, right? Going back to what we want to focus on and making our objectives pretty clear. And then the second one is more of a controlled execution phase on the doc. Thinking about being a little bit precise on what it's doing within the different steps that an automation doc does for you. And then an automation restoration step. So like Hans was saying, if something were to stop, to bring it back online so that it goes into the regular state it was when we first started testing it all together. Now, the idea behind creating this automation doc is more of a defining the different states and maintaining that state within all the different levels of that phase that we're going within our testing. Now, this is providing more of a structure within our automation, so the different steps that it's going to orchestrate in a flow that goes within the lifecycle of your testing. Now we're looking at the FIS templating guide that it is creating before that the automation doc is going to execute altogether. Now, it's passing specific values towards the different targets that it is testing resiliency with. It is thinking about we're focusing more where it says the 500-second pool in that area, and it's thinking about the duration and targeting that default app pool for our testing altogether. Now, these are parameters that are defined in our doc earlier. So when this is targeting those nodes, it's targeting the different nodes altogether in the application, and then it'll execute within the automation doc itself. This is kind of combining those 2 different services and leveraging what could be native and what is not built in, and then adding the different configurations that might not be supported. So from logging, IAM permissions, different components that could not be actively supported, and it's supporting it through automation altogether. Now, we do have a demo, so Hans, let's see it in action.
So let's take a look at all the things we built previously. So here we'll go into our fault injection service under resilience testing here in the console. and we'll see the service, the experiment that it created. You can see here that this is the template ID, and we're going to start the experiment. We're using the console now, but this can be done via APIs or CLI to invoke the experiment. Here's our web host. It's still up. It's connected to the database currently, so the service is still online. You can see here that the action is pending, so it's about to start and impair our web service. And you can see here's the action and how it is connected to the SSM document as Narita showed in that as well when we exported the JSON template. So that's what it looks like in the console. And the same thing here, you see the experiment and all the PowerShell that was written for us as part of that document generator agent, implementing best practices, logging, failback along the way, doing all that heavy lifting for us. Now if we refresh it, the instance is taken down. So we had the agent discover what was happening, and then it created the document for us, as well as then impaired the system. So far we've talked a lot about what if I don't know what I want to test, right? Discover the system for me and help me figure out what are the likely failure modes. Now let's move to the learn and respond, that last phase of our resilience lifecycle framework. What if I know what I want to test? So in this context is we had an impairment and we produced a root cause analysis of what the timeline was, what actions were taken, and we feed this document of our root cause analysis to our agentic or large language models. We can provide it better context by giving it known good experiments. This could be the fault injection service, ones owned by the service team and systems manager, accompanied by the best practice blog, or some samples from our open sourced Fizz template library. So what do good experiments look like? And what are the best practices associated with it? And then we can also give it an AWS environment to go review as well, that's production-like, to have good context of here's the impairment, here's what good experiments look like, and here's the environment. Go help me recreate an impairment that will help me validate what happened and all the checks and balances I put in place that these don't happen again. Then ideally, once we have all that built, we want to test in a like production environment, right? There's many differences at times between a dev environment and a pre-prod environment and production, so we want to test as like prod and validate that we're able to observe the impairment, and either in terms of DR, because resilience is high availability and then disaster recovery. If we're doing something, did all our playbooks that we updated to help recover from that impairment, are they all valid? Do all those work? And do our teams able to validate that? So we can take all these things into context to help validate, recover, and learn and respond from something faster. Okay, and we'll talk about what could that agent possibly look like. Again, steering it, giving it the direction of you are AWS resilience expert. You will discover what is in the root cause analysis document, you will comprehend it, you will create failure scenarios with Fault Injection Service and Systems Manager based on what you find. And again, you're going to have some inputs into your decisions. You'll be given a root cause analysis document that has timelines, that has details of root cause of what's going on. And from there, you will look at your target environment and the RTO and RPO of the application that you were provided to know all the requirements of how should the application function and what happened previously. And from there, consume this RCA document or root cause analysis and extract the failure modes. Make sure you map them to the dependencies and single points of failure that could be in the environment, and formulate testable hypotheses based on these, and then go build them for us. So again, saving time to help us build tests to validate what happened and does it actually stop it from happening again. And working with many customers, if we have no context of the application, it may take us a week or two to actually go sit with the application teams or sit with the SREs to have a good conversation on what are all the failure modes for this application, and document those, and how then to test and prevent those in the future. And then we create hypotheses from those. That could take a couple hours or days, depending on the amount of effort and what people's knowledge of the application is. And once we have those things, then we have to go build our systems manager documents, which could take a couple days to build and test if we're writing them ourselves. And then we want to spend time validating that, right? We have to test the automation. We're going to trust but validate. That was another thing from Matt's slide this morning. We trust the system to do things, but we want to validate it before we start experimenting. So we want to look at the automation document. We want to make sure everything looks good, and then begin to test this in our environment to make sure that it's doing what we want and not just running code. And so from doing our root cause, our discovery of the system to having the experiment ready to run in an environment, that could take a couple weeks possibly, depending on teams and setting up meetings and having our day jobs as well, right? And so how does AI speed this up for us, doing all the things we talked about? So we can now discover the system and inventory it to produce failure modes within a couple minutes. That was a single instance, but it took 2 minutes to fully discover what was on the box and provide me some hypothesis of what I could start testing. It then designed the experiments and the hypothesis within a couple seconds and created those documents, implementing best practices along the way. And then I can spend my time as an engineer validating those and giving feedback to those documents of what needs to change, but I'm not spending my time doing all those things. I'm being very effective with how I'm spending my time. Go build it for me, I'll test it and I'll validate it, and that allows me to get things done much quicker and spending my time efficiently as an engineer. Okay.
Now let's talk about a little bit more on the actual time savings, what it means for your team and your different organizations, right? Disclaimer, it's always gonna be based on your use case, but it's up to 90% reduction in experiment time. It's gonna go we're going from weeks to days from what Hans explained earlier. So it's not just about speed, it's also about enabling resilience. So when we're talking about the automatic discovery, it eliminates more than just manual systems or improves those different systems, right? We're thinking about removing the extra fluff. If it's going through wikis, if it's going through our internal tools, we're kind of automating and making that life cycle a little more faster for us. The agent is generating contextually all those relevant scenarios that we will likely need to test. And so it's giving you that or it's reading all those different information that it really needs, and because you're providing all the different contexts from the RCAs, the best practices, and it's also defining what is happening within the environment if you're meeting those requirements. And it's also doing it within a safely mode, so not breaking your monitoring. If you're having different applications, it's allowing you to do it in a safe environment. And so what does this really mean altogether for us? It's kind of taking you into a little bit of acceleration when it comes to your resilience testing. So think of this as more of a way to, instead of you doing everything manually, you're having someone do it for you, but you're also validating, right? It's kind of bringing those two different components, AI and human, into oneself to kind of give you a way to safely and at an accelerated way for your teams to bridge that gap as a working team instead of it being individual. So how can we implement AI into test resilience? Kind of talked about this, but Hans will bring it back into the whole life cycle.
Yeah, so we showed a bit of how we test and evaluate, right? Discover the system for me, create these things, save me some time, and then we talked about learning and respond. But these were isolated use cases in themselves, so how could we take this to the next step? How can we take this, as we like to say at AWS, what is the art of the possible to this system? We can create these into a multi-agent system responsible for different things. Here we're going to start on the left and move to the right on the top. We have a hypothesis generator. Possibly the systems manager agent that we had is a sub-agent of that hypothesis generator. It will not just take in the account of what's installed on an EC2 instance, but look at the application code, look at the environment, to holistically tell me everything that we could hypothesize for this given scenario. From there, this could create many hypotheses, but this will feed it to the next agent, which is a prioritization agent, which go tell me which one of these is the most likely to actually happen, right? Let's test the most likely ones. Let's spend our time where we should. Prioritize these examples for me. And then from there, once we have the hypothesis who have been prioritized, then we need to design the experiments, right? Giving context of what are the native phys actions again? What do I then need to go create myself? And so the systems manager document agent would most likely be a sub-agent under the experiment design, right? Go design these experiments, have context of what is native, and go beyond that where need be with safety guardrails in place. And the experiment agent would have been able to then to actually go execute these experiments for us. We can have other agents that are possibly even evaluating each of the systems manager documents we write for their efficacy. Are these following best practice? Using LLM as a judge, as you may have heard that before. We can implement these other agents along the way to make this more of a solution to say, go discover my environment, hypothesize, build experiments, and then test them for me, and then also learn and iterate. Have another agent monitoring the experiments running. Are they having the desired impairment? Are we seeing the logs come through and being able to observe what's happening? Or do I need to go reimagine my hypothesis and continue to iterate on that? And so we can put all these agents together to help us have that holistic solution to evaluate and begin. Along the way, we still want to trust but validate, so we would probably still be looking at these systems manager documents that we're producing and just validating things as we move them from deep environments. But at least it gives us a head start to go create these things and let me spend my time efficiently rather than toiling with creating documents, inventorying systems. Give me a head start.
So thinking about takeaways, because if you could take anything from a 60-minute conversation from everything you've learned, it's kind of a lot to digest. But when we think about how we're using AI with resiliency, is thinking about how it can help us detect vulnerabilities in our different complex systems, right? We're thinking more towards how that can accelerate us into being able to test faster, remediate, mitigate as much as we can, and without it just being us. And so it's helping us go beyond with what we already know and helping us map out those different dependencies that the unknown, so testing that unknown. Now, talking about that collaboration between AI and ourselves, so thinking how we can really think about all the different possible scenarios that we have not thought about or that we have not tested about or we have not tested, right? When something happens, if you get that 3 a.m. call, you already know what you're supposed to do, or it could mitigate that risk or reduce that risk of that possibility of being woken up at 3 a.m. And so by using the fault injection service framework with AI, we're really having that controlled environment, being concise with our chaos engineering and testing with a purpose. And so this is kind of accelerating, bringing that collaboration between AI and the different teams that you might have. So the real truth and the power that I like to say is that AI partnership with us. It's not replacing one component of your team, it's building a team so that the AI becomes more knowledgeable through every test, every failure, every success, but also getting that feedback from your engineers to say, is it right, is it not correct? It's validating between each other so that you're building that application that can withstand any failure at any component, wherever it might be altogether. And so this is kind of the evolution that we've seen when it comes to resiliency testing. It's building that bridge, understanding what is happening, what is not happening, and then being able to kind of learn from each other and validate and progress as the company grows over time. So what's next? Earlier I mentioned that we have something that you can implement right offhand, right? In AWS, we like to say we like to repurpose already things. So multi-agent chaos engineering is where you'll find the solution that we demonstrated today. It's all the different coding that comes with with the agents. What is the agents doing so that you can repurpose as well, test at your own risk, right? Validate it, make sure it's meeting your guidelines. And then we have the AWS Resiliency Analyst Framework. That is kind of giving you an action plan to understand define your application, move towards what are possible scenarios, failures, and also plan for mitigation altogether. And then the AWS Fault Isolation Boundaries is kind of talking about our infrastructure and how can you plan for what could be a disaster and how do you implement that and design your own application. Want to know more beyond just resiliency? We do have a booth at the Village We have multiple use cases from observability, cloud governance, cloud operations in general. So come find us at the booth. We have demos, we have swag. We all love swag. So come visit us at the kiosk. And if you have any questions, we could take questions in the back. But thank you so much for being here, and I hope you have a good reInvent.